All right, geometry, we're starting chapter 5, and believe it or not, chapter 5 is about triangles. All right, we're not done with triangles. We're going to see them for a few more chapters after this, but what we do in chapter 5, probably the best way to describe it is properties of lines within triangles and properties that all triangles have. It's amazing to think a triangle only has 3 sides, but the amount of information and the amount of properties that you can find out about a triangle is simply amazing, to be honest. So today we're going to talk about midsegment theorem and the coordinate proof. Midsegment is one type of a line you can draw inside of a triangle. And I can't stress to you enough, in the next 4 sections, we're going to have at least 5 different kinds of lines we can draw inside triangles. So it's super important to know the properties of these segments and how they differ from one another, okay? So a midsegment of a triangle is a segment that connects the midpoints of 2 sides of the triangle, okay? So if we start off and you say, okay, here's the middle of this, and just to make sure somebody knows that I mark it and then I mark both sides equal, okay? Then I come over here. Here's about the middle of this, and I mark both sides equal. Here's about the middle here, and I mark both sides equal, okay? Those little markings are super important because we want to remember that our midpoints are what is on that line. So if I join this midpoint to this midpoint, I formed a mid-segment. But I can also join this one to this one, and I make a line segment there, a mid-segment, okay? And I join this midpoint to this midpoint, and I get a third mid-segment. All of those are mid-segments. They all might have a different length, but their job is they join a midpoint to a midpoint, okay? The second definition, coordinate proof, is placing geometric figures in a coordinate plane. So we'll throw that out there. We'll get to it later, okay? We're going to start with this mid-segment stuff. Okay, so mid-segment is a simple segment you join by, you draw by joining 2 midpoints, okay? The midsegment theorem says the segment connecting the midpoints of 2 sides of a triangle is parallel to the third side. Okay, and if you look at it, it kind of looks like it, like this one looks parallel to this one. This one over here looks parallel to this one here. And this one looks parallel to this one over here. Okay, they're parallel to the segment. They're not touching, basically, okay? And they're exactly half as long. Exactly half as long. So we have a mathematical property of both being parallel and half as long. That's big. We can do all kinds of math equations because of that, okay? So let's practice some midsegment here and figure out what's going on. Here I have large triangular windows because I'm sure most of you have a triangular window somewhere in your house, right? Seems like such a natural design in a house. So we have large triangular windows segmented as shown. In the diagram DF, which is this line right here, and EF over here are midsegments, okay? And they want us to find the length of DF and the length of AB. Okay, so DF here is a midsegment, okay? A midsegment should be half of its parallel side. What side is parallel to DF? Well, it looks like BC right here. So DF is going to be half of the big side. So if BC over here is 90, what is DF's length? 45, okay? Now, I noticed that this other midsegment's 45. Please, please, please do not think in your mind they're always going to be the same length. On this example, they happen to be, but they definitely are not always the same length, okay? All right, same picture. This time they want me to find the length from A to B. So this one right here, this length A to B, okay? And A to B is not the midsegment. AB is the outside side. But we know its midsegment right here is half of it, okay? So if you think of this, if you think of midpoint, I usually write it like this. Midsegment equals half of the parallel side. Well, if I want the parallel side by itself, how do I get rid of the 1/2? I multiply by 2. So I want to take twice the midsegment to be able to find the parallel side, okay? So this one, they didn't write any words here, but that's what we want to do. We want to take that little amount of 45, we want to double it, and we get the big one is 90 inches. And again, I want to stress that this example, the sides happen to be the same, the midsegments happen to be the same, but that is not the case for all triangles. So please don't think if one outside side is 90, the other one has to be, okay? All right, for example 1, it says, go right back up to the same picture we were looking at, triangle ADF. ADF is this top one up here, okay? So I'm just going to redraw it here so we can work with it. Let's see, D's over here, A's up here, F is here. And we already know that we found that we have 45 inches on this mid-segment that DF was, okay? It says, what is the mid-segment opposite DF? So here's DF. Can I find another mid-segment up here? Sure, I find the midpoint between these two. I join them. How long would this mid-segment be? Half of its parallel side. So it'd be half of 45. So we get a 22.5 for that mid-segment, okay? Could we continue to make smaller and smaller mid-segments? Sure, and they'd get smaller and smaller in length, right? So mid-segments are not limited to just one. You could continue to draw, but typically we just draw the one. A mid-segment joins midpoint to midpoint, and it's exactly half of its parallel side. All right, we have a picture over here. It says in the diagram at the right, QS equals SP. QS equals SP. I mark that. What does that make point S then, if both sides are equal? I would say I'd make it a midpoint, right? So S is the midpoint. And it also tells me PT equals TR, so PT equals TR. So what does that make point T? A midpoint. And by that, knowing that those are both midpoints, what would we call ST? If it joined midpoint to midpoint, it is a mid-segment. And if it's a mid-segment, we know that ST there has to be parallel to QR because of the definition of a midpoint, of mid-segment, right? By the definition of a mid-segment. Okay. So if we can prove that that is a mid-segment, which we did, then it has to be parallel to its opposite side. Okay. It says in the picture for number 2, it says in example 2, if V is the midpoint of QR, what do you know about SV? So if V is the midpoint up here of QR, what do you know about SV? Well, S was a midpoint, V was a midpoint. So what does that make SV? SV is a mid-segment. Okay, and because it's a mid-segment, it's going to be parallel to its opposite side, which is PR, and it's going to be exactly half the length of PR. Okay, so as soon as you know something's a mid-segment, you have 2 rules about it. It's parallel and it's half the length. All right, let's do a little coordinate proof. It says, placing a figure in a coordinate plane. Place each figure in a coordinate plane in a way that is convenient for finding side lengths, and assign coordinates to each vertex. Okay, let me do one maybe the wrong way first to show you kind of what logically you would do. So I give you a coordinate plane, right? And I say, draw me a square in it, okay? How many of you would draw your square to look like this? Finding points in there and draw it like that. Would you draw your square slanted like that? Especially if I told you, oh, now I want you to find the length of each side. I mean, I know some of you love the distance formula, but do you want to have to use the distance formula? Or is there a better and more convenient way to draw a square in a coordinate plane? Okay, that's kind of the idea we're talking about here. When we say in a convenient place, if we have to find the side lengths, I wouldn't draw it slanted like that. I wouldn't draw it hanging out in the middle of my first quadrant. I would use some things like the axes, right? The x-axis, the y-axis. I would use things like 0, 0, so I had nice points. I would try to make it as much horizontal and vertical as possible so that I didn't have to use the distance formula, okay? So that's the idea they want you to know here is if they say you put it in the coordinate plane, put it in a good spot, okay? So it looks like we use 0, 0 here. And what's nice about a square? All the sides are exactly the same length, okay? Now, we don't necessarily, in this case, know the length, but they just said if we go to the right, S places, so that makes this S 0. Well, if I go up S, remember that's 0 to the left or right, and then S up. So that makes this point over here, over S, up S, okay? So we have all the same length, no matter what it is. That way, if somebody tells you that S is 10, you're like, oh, then I'm at 10, 0, 0, 10, and 10, 10, right? We could change that value of S, but we know that we could just plug it into those, okay? So what's super nice here is if I had to find the distance and stuff, it's easy to find the lengths because I can just say, oh, it's S across, because I'm allowed to count the spaces, S spaces, right? So, and it's also easy to find things from 0, so that's why we like to use that origin down there, the 0, 0. So we placed one vertex at the origin and one or more sides on an axis if we can, because it just makes it easier. We probably don't want to do this one in the margin because it's not easy to find lengths and such. Okay, now a square went on there really nice. Not all of them do that, right? So we have to kind of think what's going on. So the second example they give me is just draw an acute triangle, okay? I'm still going to start at 0, 0, and I still want to use this axis, so I do that. Now, for my acute, I can't use my next axis because that would make a right triangle, so I come in a little bit, and then I go back down. So, important thing, I start at 0, 0, okay? How far did I go over? I don't know. They called it B, okay? And then 0. Now, over here, it looks like they didn't go as far. I'm going to be honest, they used A, and they went up, I don't know, a height or something like that. You could make them any variable you want. Here's the key. If you make those A and H and B, you're telling somebody they are 3 different values, okay? Because if you made this one A and A, that means as far over as you went up that high, which it's possible. But if you use different variables, you are representing that you use 3 different variables. You use 3 different variables, you have 3 different lengths, right? So just remember the different letters will signal different lengths. You can't have, in a case on a coordinate plane, if you have 2 different variables, they will be 2 different numbers. You cannot make them equal the same thing, okay? And I should come back here and write that S was my side length, right? Okay. Right now, this seems kind of funny putting these variables on. Let's go to the next page, though, do some examples, and maybe that will make more sense, okay? Okay, so it says in example 3, part A, find the length and midpoint of the diagonal of the square. So they actually took this square that we drew on the other page of 0, 0, S0, 0S, and SS, and they put it back on this page. And it says, find the length and midpoint of the diagonal. Remember, a diagonal goes from corner to corner. So they were nice to us, and they took it from 0, 0. Don't know what's going on. They took it from 0, 0 and put it up here to SS, okay? And they said draw it and find its midpoint, right? It didn't, oh, it did say up here, find the length, right? Well, guess what? It's slanted. So we get to use the distance formula, right? So don't forget our distance formula. x2 minus x1 squared plus y2 minus y1 squared, okay? And in this case, my one point is 0, 0, and my second point is SS, okay? So I take my big square root, right? I subtract my x's, s minus 0 squared. Subtract my y's, s minus 0 squared. All right, well, what's s minus 0? S. What's s minus 0? S. What's s squared plus s squared? 2s squareds. All right, can I take the square root of any of that? Well, I can't on the 2. There's no pretty in it. But when I look at s squared, a square root saying how many pairs of s's do I have? Well, I have 1 pair of s's, so I can pull that s out, that 1 pair, and leave the 2 inside, okay? That's the length of my diagonal, is s square root of 2. Now, you're like, well, what does that give us? What's that mean? Well, here's the deal. What if I told you that that square had a length of 10? Well, if this side's 10, and this side's 10, and this side's 10, and this side's 10, this right here is telling us that my diagonal would be 10 square root of 2. I just plug my side number in there, and that's what I get. So I could change it up, and I could say, well, what if my side lengths were 219? Well, the diagonal would be 219 square root of 2. If I told you the side lengths were 44.64, you would tell me the diagonal was 44.64 square root of 2. So what it does is it gives us this, like, kind of a general rule that we can just plug in. And it is a nice thing so that if we were doing a lot of different samples, we always know what that diagonal is going to be. Okay, we're still in the same problem, and this time, though, we're going to find the midpoint. Again, using that. Don't forget your midpoint formula was add your x's and divide by 2, and you get your midpoint, x midpoint. Then you take your y's, and you divide by 2, and you get your y in the middle. Okay, that's what we do for midpoint. So if we're finding our midpoint, we're still using 0, 0, and SS. So I add my x's, 0 plus s, and I divide by 2. I take my y's, and I add 0 plus s, and I divide by 2. Well, what's 0 plus s? S. Divided by 2 is just s over 2. What's 0 plus s again? S. Divided by 2 is s over 2. So I get this ordered pair of s over 2, okay? Again, it seems silly. Why do I care that I have s over 2 and s over 2? Go back to my example. What if the side lengths were 10? Then I'd put 10 in that s spot. 10 divided by 2 is 5. 10 divided by 2 is 5. 5, 5 would be my midpoint, okay? What were my ugly numbers? 219. I don't want to use it. It's odd. What if I said 220? My side lengths were 220 and 220. 220 divided by 2 is 110. 220 divided by 2 is 110. So my midpoint would be 110, 110. Okay? So it gives us this generalized rule, and that's the benefit of coordinate geometry, is we can come up with a generalized rule and use it over and over and over with different numbers. Okay? All right. So let's try a couple more. And I know it doesn't always seem like, you're like, why would we do this? But there's a time and place for these, okay? So we do want to know how to do them, okay? Let's get our coordinate plane going here. And this time we want to have an obtuse scalene triangle in the coordinate plane that it's convenient for finding side lengths. Okay. Anytime we start anything, where's the best place to start them? At the origin. So there's one of my points, and I'm going to label it 0, 0. Okay. I want an obtuse scalene triangle. Okay. So I can't go straight up because that would give me right. So I'm going to go a little bit to the left over here, okay? So let's make up a point for that one. About how far to the left did we go? By the way, I want it to be a letter, not a number. You want to go to the left? K, okay, I can go K. Because we went left, my x needs to be negative K. How far up do we go? H, okay, I can take H. Okay. There's no wrong answer right there. And the only thing you really have to be careful with is make sure your x is negative, okay? On the right, I want to be able to find these side lengths if I have to. I already know that's going to be a distance formula, but what if I go straight over, okay, and put my next order pair? That way I at least can count that side. How far over did I go? T? Okay. Did it go up or down at all? No, so I put a 0, okay? And I have finish out my triangle, okay? And it looks like, at least on mine, I'm going to end up having 1, 2, 3 different side lengths. Obviously, I would need distance formula for 2 of those, but I'm going to have different side lengths, so that will make it a scalene triangle, okay? And it's obtuse because my angle I can clearly see is larger than my 90, okay? The letters you use, there's no wrong answer, okay? No wrong answer there. You can choose different letters. The big key thing is I really need this negative right there because it's on a coordinate plane and I went left of the axis, so it has to be negative. Other than that, draw away, right? Okay, let's go to the margin. It says draw a rectangle in the coordinate plane in a convenient way with sides of 6 and 3. Label the vertices, okay? Can't stress this enough. It's on your worksheet tonight. Label the vertices. If you just draw it, it's pointless. Okay, there's no reason for just drawing something. The labels, the ordered pairs are the most important thing we can put on there, okay? So I'm going to draw myself a coordinate plane. And yeah, you'll notice I didn't even draw much of the second, third, or fourth quadrant, because to be honest, I don't want to use them, okay? I'm going to actually do this 2 ways, just so you know, okay? Don't worry about my slantedness. I didn't want to cross off worksheet there. Okay. So it says put them in the coordinate plane in a convenient way with sides of 6 and 3. Where do you want to start this rectangle? I'd put it right there at 0, 0. Okay, how far to the right would you like to go? You want to go 3 to the right? Okay, 1, 2, 3. So what ordered pair am I at? 3, 0. Okay. How far up do you want to go? Looks like we have to go up 6, right? 1, 2, 3, 4, 5, 6. There's my new dot. Okay, we have one more to find. It's a rectangle, so I put a dot right there. And what's the ordered pair there? Actually, I should come back to this one here. I went 0 to the left or right, and I went up 6, so I'm at 0, 6. So my last ordered pair, where am I at? Over 3, up 6, so I'm at 3, 6. There's my ordered pair. There's my rectangle drawn in a convenient way. It's as easy as that. Could you draw this rectangle on your page in a different way and still get it correct? You can. What if you did it this way? What if you started at 0, 0, and you went over 6? 1, 2, 3, 4, 5, 6. So if you did that, I'm at 6, 0. How far up would you have to go? 3. So you're at 0, 3. So this time when I make my last point, I'm over 6, up 3, so I'm at the point 6, 3. Does this rectangle also have lengths or sides of 6 and 3? Sure. So there's more than one way to draw it, and the key is you need to label your coordinates so we can make sure that it still fits the rules of the right length, okay? You have a couple of them on your homework. Please, please, please draw them. Here's another thing, which will be convenient on your homework. On one of them, don't make the lines all 1, make the lines all 2, okay? So make it like scale the drawing, so each line on the graph counts as 2, and then your picture will fit in the graph that I gave you, okay? All right, one more here to do. It says in example 4, find the length and midpoint of the diagonal AC, okay? So if you peek back up at our square up there at the top, right? So that square, let me kind of draw it again. I had this square here. It was at 0, 0, S, 0, 0, S, and SS. All right, this was A, B, C, D. Okay. So same square as above, but this time they want us to change it up and find the midpoint of diagonal AC. Okay, so we're going to find this midpoint instead. So we changed the diagonals, okay? So remember, midpoint is, it says the length as well, right? Length and midpoint. So we're going to do the same thing we did above, but with different points, okay? So I'm going to do AC, and I'm going to do the square root. And remember, my points are 0S and S0. So I'm going to subtract those x's, s minus 0 squared. I'm going to subtract those y's, 0 minus s squared. Well, s minus 0 is s, and I'm going to square it. 0 minus s is negative s, and I'm going to square it. S squared is s squared. Negative s squared, because that negative's inside the parenthesis, so I go negative s times negative s, I get a positive s, and I get positive s squared. I get 2 of my s squareds. Remember taking the square root. I can't do anything with the 2, there's no pretty, but what's the square root of s squared? S. I get the distance as s squared root of 2. Isn't that what I got above for the other diagonal? Are the diagonals equal? I think they are in a square, right? So it makes sense that using even different order pairs, I get the same answer. All right, let's find the midpoint. So I have 0s and s0, and I'm finding the midpoint. So I add my x's, 0 plus s divided by 2. I add my y's, s plus 0 divided by 2. Well, what's 0 plus s? S divided by 2, s over 2. What's s plus 0? S divided by 2 is s over 2. I get the same midpoint. Different diagonal, but I get the same midpoint. But remember, my other diagonal, it goes through the same midpoint, doesn't it? So it makes sense that the point is the same on both of those diagonals. All right, Coordinate geometry uses variables instead of numbers on some of the points, okay? So you're going to practice these on your homework. Okay, I do want to kind of bring your attention to your homework on that worksheet. Let's look at 15. Okay, so look at your worksheet number 15. Going to just do a quick setup for you. Okay, I want to stress this equation. In our notes, we talked about the midsegment equals half the side. Half, I'm going to be honest here, the parallel side, right? So make sure we know what that is. So the midsegment's the inside one, the parallel side's the outside one. So when I look at number 15, it's talking about EF, GH, okay? Well, which one's which? Which one's the midsegment, the smaller one inside? That's EH, right? What is the parallel side? Well, that's GH, okay? So here's my formula, basically. This is what I'm plugging into, okay? So if they tell me that EF is 2x plus 7, I plug it in over here. If they tell me GH is 5x minus 1, I plug it in here, okay? What are you going to do with the 1/2? I'm going to be honest, I don't want to distribute that in. That makes a bunch of fractions, and I don't like fractions. You're right, multiply by 2. What I do to this side, I do to this side. That cancels. I get 5x minus 1. Over here, this 2, be careful. It needs to go to both things on this side, the entire side. I get 4x plus 14. Okay? I'm going to leave you at that. Solve for x, plug it back in to get the length you're supposed to find. Okay? But think about this equation and use that frequently on that worksheet for those ones that are talking about midsegments. Okay? All right, if you have any questions, let me know.